Hello and welcome class. So in last class we were studying about how a sound wave propagate and we learned that sound wave propagate through the vibration and sound wave need a medium to propagate and medium can be solid, liquid or gas and I have explained it through an example that how I am speaking and my voice is going in your ear. So, what is happening? My vocal cord is vibrating, and through that vibration, the air molecule around me started vibrating in its equilibrium position. It have started vibrating, and the vibration moves from one particle to another particle. And in the end, that vibration reaches your ear, and you hear the sound. You get a sensation of hearing that is sound. So, how sound is propagating? So, sound is propagating through a medium. Currently, the medium around me is gas. What is the medium around me? The medium around me is the gas. And how gas molecule are transferring the sound? It is actually transferring the vibration of the particle. The particle is not moving by itself. Particles are just vibrating and that vibration is transmitted from one particle to another particle and that's how sound move. Now a question arises that in which medium the speed of sound will be higher. What will be the answer according to you? Will it be higher in solid, liquid or gas? In which medium the speed of sound will be higher? To answer this question, we have to understand the mechanism how sound is propagating. So we know that sound is propagating through particle and what particles are doing? They are transmitting the vibration from one particle to another particle. If particles are far away, then it will take more time for vibration to reach from one particle to another particle. And if particles are close, then vibration can be easily transmitted from one particle to another particle. And how fastly the vibration is transmitted define the speed of sound. If particles are close, the vibration will be transmitted very fastly and the speed will move faster. And if particles are far away, then the vibration will transmitted from one particle to another will take time. So correct answer is solid. In solid, the speed of sound is higher than comparison to gas and liquid. And what is the reason behind it? Speed of sound is higher in solid. Okay. Maximum in solid, then liquid, and in the end, gas. Why this is the order? Because in solid, particles are closely bound. In liquid, particles are little bit far away, and in gas, particles are very much far away from each other. So in solid, the transmission of vibration will take place more faster in comparison to gas and liquid. So the speed of sound is higher in solid. Clear class? So this is all the topic we learned in last class. Now we will continue further. Sound moves through a medium from the point of generation to the listener. How sound propagate or moves? It moves through a medium from the point of generation and the thing which is generating the sound is called source. So source is actually point of generation. So what source is doing? Source is vibrating. Source is vibrating through which the air molecules around it start vibrating in its mean position, and this vibration is traveling from one particle to another particle. It is clear to us that particles are not traveling. Vibration is moving from one particle to another particle. When an object vibrates, it sets the particle of the medium around it vibrating. When any object start vibrating, what it does, it start other particle around it, particle of the medium around it vibrating. The particle do not travel. This is very important line, student. The particle do not travel to take sound from one place to another. The vibration travels. Clear? Now we will move further. A particle of the medium in contact with the vibrating object is first displaced from its equilibrium position. And I have explained you what is equilibrium position. The rest position of particle is known as equilibrium position. Rest position of particle is called equilibrium position or mean position. Equilibrium position Okay, so this particle is in equilibrium position. A nearby particle of it is vibrating. This particle is vibrating. Then this particle will force its adjacent particle to vibrate. So this particle will also start vibrating. It means even this particle will also start getting displaced from its position of rest. Okay. It then exert a force on adjacent particle. That particle which is vibrating will give a force to its adjacent particle, which set this adjacent particle vibrating, as a result of which adjacent particle get displaced from its position of rest. So we can clearly see from this diagram that this particle which was initially at rest start vibrating from its equilibrium position. After displacing the adjacent particle, the first particle come back to its original position. When the vibration of this particle transfer to this particle will come to rest and this will start vibrating. Then this particle will force its adjacent particle to vibrate and this will come to rest, and that's how sound propagates. Clear, student? This process continues in the medium till the sound reaches your ear. This process of transferring vibration will keep continue in the medium till the sound reaches to our eardrums, and it will make the eardrum vibrate, and the vibration of our eardrum will generate a signal in our brain and we will get a sense of hearing. That's how hearing take place. The disturbance created by source of sound in the medium travel through medium and not the particle of medium. This line is again saying the same thing, that particle does not travel, only the vibration or the disturbance travels. Okay. So disturbance travel, and we can make disturbance in a form of a wave. So a wave is a disturbance. A wave is a disturbance that moves through a medium when the particle of the medium set neighboring particle into motion. So what this line is explaining us, this is very important line. It is defining what is sound wave. So this is a source. Let us assume this is a source which is vibrating and producing disturbance in the medium. A nearby particle starts vibrating from its mean position. Then this vibration will get transferred to another particle, which will start vibrating, and this particle will come to rest. And then this particle will set another particle to vibrating, and this one particle will come to rest. And if we plot this disturbance versus distance graph, we will see a graph like this. So what is happening? Here was one particle which will start vibrating. Then it set nearby particle to vibrate, and this will come to rest. Then another particle will start vibrate, and that's how this graph will generate, and this graph is known as wave. I hope this picture is clear in your mind. What is wave? Wave is just a disturbance in the medium. Okay. And we have created a boundary, and it creates a wave. The particle of the medium does not move forward. We are repeating this line again and again, that the particles does not travel, only the vibration or the disturbance is carried forward. Disturbance is carried forward by the particle, but particle does not move from its position. This is what happened during propagation of sound in the medium. So this is what happening in the propagation of sound in the medium, and we can visualize this process through a wave. And this is the important line. Sound wave is actually characterized by the particles of the medium, and those waves which are characterized by the particle are known as mechanical wave. So this is the definition of mechanical wave. Sound waves are characterized by the motion of the particle in the medium, and this is called mechanical wave. Okay, this is important point. This is the definition of mechanical wave. What is the most common medium around us through which sound travel? The most common medium around us is air. Okay, so air is the most common medium through which sound travel. When a vibrating object moves forward, it pushes and compresses the air in front of it, create a region of high pressure. Okay, this is a vibrating object. When a vibrating object is moving forward, what it will do? It will compress air particle in some region. Also, because we know that sound wave is something like that, so it will compress some region and it will expand some region. The compressed region will have high pressure, and this region will have low pressure. And this compressed region where pressure is high is known as compression. What it is called? It is called compression. And that region with low pressure is known as rarefaction, which we will show in a diagram. So this is the diagram. A tuning fork is vibrating from its mean position, creating a compressed region and a less compressed region. The compressed region is called as compression, and the less compressed region is called rarefaction. The compressed region has more number of particles in it, and it is compressed, so it has high pressure, where the rarefaction region have low pressure. this compression start moves away from the vibrating object. So a vibrating object is moving forward. It is creating compressed region and a less compressed region. This compressed region is moving forward or moving away from this vibrating object. When vibrating object move backward, when this vibration moves backward, it create a low pressure region called rarefaction. So highly compressed region which have more pressure is called compression, and the region with the low pressure is called rarefaction. When vibrating object is moving forward or vibration is moving forward, it will create compression region, and if the vibration moves backward, it will create a rarefaction region. As the object moves back and forth rapidly, when an object moves back and forth rapidly from its mean position, this is the vibration, and it is moving backward and forward rapidly, it will create a series of compression region and rarefaction region in the air, and this makes sound wave to propagate from one medium to another. Clear, class? This is the diagram that a tuning fork is vibrating. So it is doing to and fro motion rapidly. When it is moving, when the vibration of tuning fork is moving in this direction, forward direction, compressed region is created, which has more number of particles and high pressure. And when this vibrating object moves in this direction, backward direction, it will create a rarefaction medium with less number of particle and low pressure. And this vibration is very rapid, so it will create a series of compressed and rarefaction region in the medium, and that's how sound propagates. I think it is clear now. Now we will move forward. So we have already understand that compression is the region of high pressure and rarefaction is the region of low pressure. It is clear, class? Compression means high pressure. Rarefaction means low pressure. And because pressure is related to number of particles, so compression will have high pressure. It means it has a high number of particle, large number of particle. And rarefaction has low pressure. It means it has small number of particles. Because assume that you have a container, okay, two container of same volume, but one container has large number of particles and other container have low number of particles. So which container, container A and container B, which container will have large pressure? And it is clear that that container which has large number of particle will have large number of large number of particle will have high pressure and it will have low pressure. So pressure is associated with the number of particle. Large pressure. So this is the point saying that pressure is related to the number of particle of a medium in a given volume. Volume is same. If the volume is same, then the number of particle will define which container will have high pressure and which will have low pressure. If number of particles are small, then the pressure is low. If the number of particle is large, then the pressure is high. Is it clear, class? More density of particle in medium give more pressure. Larger the number of particle, it means if the density is large, then the pressure is large. Thus, propagation of sound can be visualized as propagation of density variation or pressure variation in the medium. So, propagation of sound can be visualized as the pressure variation. That one region has the high pressure, then another region has the low pressure, or the density variation. That one region will have high number of particles and other region has lower number of particles. I hope it is clear. Now we will move forward. Now we will solve some questions related to this chapter and try to give you detailed solution of these questions. What is question number 1? Question number 1 is asking how does the sound produced by a vibrating object in the medium reach your ear? How does the sound produced by a vibrating object reaches to your ear? A vibrating object like a tuning fork is producing sound that is clear, but how this sound is reaching in our ear? And what will be the answer of it? How sound propagate? Sound propagates through a medium. Okay. So this vibrating object or this tuning fork is setting the particles of the medium vibrating, and the vibration is transferring from one particle to another particle till that it will reaches our ear. So through the medium a sound propagates. Answer is when an object vibrate, it necessitates the surrounding particle of the medium to vibrate. Is it clear, class, that when a particle vibrate, it sets surrounding particles to vibrate? The particles that are adjacent to the vibrating particle are forced to vibrate. That if one particle is vibrating, it will force its surrounding or adjacent particle to vibrate. It will transfer its energy to another particle. Hence, the sound produced by vibrating object in a medium is transferred from particle to particle till it reaches your ear. So how sound propagate? It sound propagate through vibration of particle of the medium, and that vibration is getting transferred from one particle to another particle till it reaches our ear, and that's how we hear sound. I hope this answer is clear. Now we will move to next question, question number 2. And what is question number 2 saying? Explain how sound is produced by your school bell. Okay. So how school bell work? A school bell is consist of large metallic disc and a hammer. When any person hit the school bell with an hammer, we we hear a large sound. How this sound is producing? So after hitting the hammer on the school bell start vibrating, and we know that all vibrating object produces sound. So that's how sound is produced by our school bell. Let's see its detailed answer. When the school bell is hit with a hammer, the school bell moves forward and backward, producing compression and rarefaction due to vibration. And that's how school bell produces sound. Okay. a school bell is consist of large metallic disc, and a person hit that disc from a hammer. When you hit the school bell with a hammer, the school bell, um, the disc start vibrating forward and backward, creating a compressed and rarefaction region around it, and that's how it produces sound. I hope this question is clear. Now we will move to next question, and that question will be the last question of this class, and we will study other question in next class. What is question number 3? Why are sound wave called mechanical wave? In theory part, I have explained you what is mechanical wave. If a wave is generated by the particles, then that wave is called as mechanical wave. And sound wave is also generated by the vibrating particles. So sound wave is a mechanical wave. Sound wave require a medium to propagate to interact with particle present in them. So sound wave are called mechanical wave. Sound wave consists of vibrating particles. When particle vibrate and it's transfer its vibration to another particle, sound wave is generated. So this wave is generated by the vibration of particle, and any wave which is generated by the particles are known as mechanical wave. So sound wave is a mechanical wave. So I hope this question is clear to you now. So in today's class, we have mainly focused on how sound wave propagate. In next class, we will learn about other characteristics of sound. I hope this class is clear to all of you. Thank you so much.